Most of you will probably be familiar with this weird warping effect that you see in videos of fast-moving objects, rotating propeller blades, or footage that was recorded from a moving vehicle. And this warping effect is caused by something called rolling shutter recording, which is what we're going to talk about in this video. Rolling shutter refers to the way images are recorded in a digital camera. So let's go back to the basics for a moment. Video is obviously a sequence of images. So we have a video camera, we point the video camera at something that we want to capture. The video camera will then capture many images of that in a sequence, and it will store those images into a memory card or something. And then later on we can play back that sequence of images, and that's the video, right? It's basically just a slideshow being played back very rapidly. Now let's zoom in a little bit more on the capturing of these images. So inside a camera, what we've got is a lens which projects the actual image from the outside world onto something called a digital sensor. So a digital sensor is basically a massive grid of tiny little light receptors, which are the pixels of the image. And all of these light receptors are measuring the intensity of the light that they receive. And recording an image basically means reading the value of every single one of these light receptors and storing these values in a file. And then later on a computer can reconstruct these values into an image. So that's what we've got. We've got a lens that focuses light onto a sensor, and that sensor is repeatedly capturing images of the light that is falling onto it. So now, what's causing this weird warping effect in the video when we're filming fast-moving objects or rotating propellers or things like that? Well, that's because of the way we read the information from all of these light receptors on our sensor. So first of all, here's what you might expect to happen when we are capturing an image with a digital sensor like this. So we have a sensor, and we have an image, basically a pattern of light that is projected onto it by a bunch of lenses, and then when you press a button or when you start recording or whatever, then the information from all of the pixels from all of the light receptors on this sensor will be gathered and will be stored onto an SD card simultaneously. Except that's not what happens in the real world. In the real world, we do not capture all of the pixels' data simultaneously. So say we have a very crappy sensor of 5 by 5 pixels. So that's 25 pixels or 25 light receptors in total. We project an image onto this using a bunch of lenses, and then we capture an image. Now, we don't capture all of the data at the same time. We don't take all of these levels from all of the pixels in one go and store them in a file. Instead, we run through this sensor line by line. So we start with the top line of pixels, and then we move down and we move down and so on. So we essentially roll across this sensor. That's why it's called rolling shutter. We obtain the information from these pixels not all at the same time. We do it in a rolling fashion, going from top to bottom. And that creates a very interesting situation, because it means that the top part of the video frame will be slightly behind compared to the bottom part of the video frame. Right, there is a little bit of time difference in between them because it took some time to roll down through that entire grid of pixels. And that doesn't matter, right now it doesn't matter. You're watching a video that has been captured this way with a rolling shutter camera, and you've probably not seen anything weird, and that's because I'm not moving very fast. However, if we are filming something that does move very fast, so a rotating propeller, or we're moving at, say we're filming out the window of a driving car, then it starts to matter. Because when objects are moving very fast in front of the camera, the time difference between the top and bottom part of the frame starts becoming an issue, and then the object in the video will start looking kind of weird and bent. and that's where this effect comes from. Now normally it doesn't really matter that much, even if you're filming something that is moving fast, or a helicopter with rotating blades, even then it just looks kind of cool and it doesn't really matter. It does, however, matter a lot when stabilizing a video. When stabilizing a video, this warping effect caused by the rolling shutter is an absolute nightmare. Say we have some shaky footage, okay, and we want to stabilize this footage, so we download it into a computer, into a video editing software, and then we say, well, let's now stabilize this footage, right? Let's use digital techniques to make this footage look more steady. So the way this works is the computer simply tracks a bunch of points in the video and then tries to move around the video frame in order to compensate for the original movement of the camera. In theory, the computer should be able to do this perfectly. However, the camera has a rolling shutter, and when you're shaking a camera, shaky camera footage, the camera is moving quite a bit, which also causes this warping effect that we talked about earlier on. Which means that the computer is going to be able to stabilize the footage, but it's most of the time not going to be able to remove the warping effect that we talked about. And so you're going to get footage where, yes, it's steady, but you still see this weird bending and warping going on, and that makes it immediately obvious that this was shaky footage. So when you're trying to stabilize video, rolling shutter can be a massive problem. In other situations, it's just kind of funny. Anyway, that's what a rolling shutter is, and that's what it does to your videos. I hope you've enjoyed this video, and of course, thank you for watching.